Hello. Hello. Didn't even need to get out the OBS settings panel. Let's front light. That's better, right? Oh, that's very, very shiny. What's the point of milk without a frother? There is none, which is why I didn't get milk. I should have brought my travel frother. Muted? No, I'm not muted. What are you talking about? Why is this being written as a comment? Because this is part of a long series of how to do things in this programming language that are all code. This will have some code toward the end. This one, though, is much more text heavy than any other ones. You know, they're all different. Just changing it up. What do I use for audio, sound, and Sokoban? Well, we have our own sound mixer. However, because the audio contractors that we are working with want to use this WWise interface, we have integrated that for the time being, and we're using that to play sound, but I really don't like that at all, and we're going to have to get rid of it long term. Tonight's snack, I don't want to go through tonight's snacks because I ate a lot of them before the stream, and honestly my stomach is not very happy with me about this. So did the witness have WWise? No, it's used a mixer that I wrote. What file format? For audio? What we just I mean, for WWise it has its own packaging, right? Prior to that, in Witness and stuff, we would use what's it called? We would use waves with the compression turned on, the 80 PCM waves, or we used Vorbis files for very long audios, like all the environmental sounds and stuff like that, and the audio logs and all that. But shorter sounds, or sounds that, you know, many, like things like, you know, objects in the world making short sounds like puzzles and stuff, those were all wave files because we didn't want, you know, if you try decompressing too many things at once, that could be bad, because decompression of OGG isn't that fast. So, you know, we sort of only wanted a maximum number of compressed sounds playing at once, of OGG compressed sounds, right? Adaptive PCM is so fast to decompress, it doesn't really matter. Would I change Tekla if I had more money? Probably yes. I wrote my own 3D mixer, yes. It's not that hard. It's way easier than 3D graphics. Way easier. Like 100 times easier than 3D graphics. That is not an exaggeration. This political season has you anxious? What I'm anxious about is not directly the political season, but the fact that almost everybody is displaying that I cannot trust or respect them. So I suddenly feel mostly alone in the world this week. And that's interesting. And I'm just going to take that knowledge forward into the future. Would I say designing and implementing this new programming language is the hardest project I've worked on? No, the games are harder than the language. Guys, programming languages aren't that hard compared to other things. It's just people haven't done that good of a job on them, honestly. Like making The Witness was way harder than making this programming language. No question. No question about that. Are we talking close friends or randoms? Both. Both. I mean, I don't have that many close friends anymore. In part because of this kind of thing, but spread out over a longer time. But mostly just people on the internet and or companies and or press outlets, right? Almost all of them are showing themselves to be unworthy of respect. So I don't know what to say about any of this, except that. Ever thought about making a moneymaker game to have more money for the good games? A little bit, but what you will notice is that you have never seen that strategy succeed in the world. Nobody that I know of has ever done that successfully. A, because making the moneymaker game successfully is very hard. Otherwise, everyone would be doing it. And then B, what you find is that by turning yourself into the thing that makes the moneymaker game, you can't exactly turn around and do anything else besides that anymore. You've changed what you are. How many people are working on the compiler project right now? Just me. Did I see that most of Market Street is boarded up? No, I haven't been in San Francisco for a month because it sucks. Is this in preparation for the election or something? What graphics APIs do we support? We support every graphics API. Watching Eric W. on Lex's show kind of freaked you out. Eric has a family, so it makes it a little different for him. I don't. I do think, I don't know, I found Eric's responses a little bit strange, but only he knows exactly what what he's talking about. So I don't know. Ever have a discussion with a tech billionaire? I've had discussions with people who are pretty much guaranteed to become tech billionaires in the near future. But like actually people who were billionaires at the time, not that I know of, but maybe. I mean, I've hung out and talked to Tim Sweeney a long time ago, and I'm pretty sure you'd consider him a tech billionaire now, I guess. But even the last time I talked to Tim was really long ago. And I never really knew him that well. I'm going to stop tweeting about new features because people just never stop asking me about them. It's like, guys, let me do my thing, okay? I mean, it's good. It's good because it means people are excited and interested in the language, but it just makes me sad because there's always too much for me to do, and there's never enough ready. And like with people asking me about it all the time, it just makes it psychologically more difficult. So I don't know. I may say even less about the compiler just because this happens all the time. Some are new here, that's why you might get repetitive questions. Oh, of course. I mean, that's the thing is, that's what this medium is people drop in, drop out. Even people who aren't new here will show up 30 seconds after I explain something at length for 20 minutes and say, what about this particular thing? And I'm like, I just talked about that for 20 minutes. That's just what Twitch is. So, yeah. If Tim has 5.3 billion, where's Gabe N at? I have no idea. Probably Gabe has a lot of money. Do I know the Collison brothers from Stripe? Pretty sure they're tech billionaires. I do know them. I don't know that they're tech billionaires because Stripe is not a public company. I mean, so they would have no way of liquidly being billionaires. I'm pretty sure the valuation of Stripe is very high, right? But it's a private valuation right now, right? So that's a little, it's just a little bit of a different situation. If Stripe ever IPOs, then that changes, right? Or if they decide to sell it, but I doubt they would do that. Would I do a conference for supporting the language? I don't know. Again, I don't know. We'll see how it feels to do something like that. How far along is the language in terms of completion? -7 plus 4i%. If I could have a phone call with Elon Musk, would I want one? I don't know. I don't really have anything to talk to him about. Like, I wouldn't want to waste his time saying, hey, man. Managing companies, maybe no, because my company is not only is it a totally different size than anything he does, but it's a totally different way that it works. There's no overlapping conversation, really. Would I ever participate in a Lex podcast? Yeah, I would do any of those, like long form podcasts where the host is good at doing interesting conversations. Like that whole medium is great. Did I move to Texas? No. Yeah, like the Oxide podcast was really fun to do. We had plenty to talk about. All right, let's get to this thing that we're doing. I want to start by just sort of rereading what was written last time and see if I want to change anything. See if I don't like where it's going or if I feel like it skips over anything, and then we'll continue adding. Okay. but the you know, this is not necessary. Right there. That's just extra words. Manipulating little pieces of state, much smaller and more particular compared to the I don't know. I'll rephrase that later. HTs. Oh yeah. Okay. See, the first couple paragraphs yesterday or the other day when we wrote this, I just wasn't into it, and my brain wasn't geared up. And then right around when we get to this point, it's like my brain is starting to form actual sentences naturally, and it works better. Or maybe that's when the sugar kicked in. Achoo! Oh no, I've got coronavirus. The Lisp thing here was just sort of shoehorned in. I'm using the phrase higher level so many times here now, because this pattern of going even higher level continued for ever more abstracted language ideas. Continue the trend. Both in the realm of compiled languages like C and in tradition. Accelerating targeted languages like Lisp. To what extent the tradition these languages were all attempts to continue. Yeah, this is all still repetitive, but I'll leave it for now. The idea is fine. But somewhere between 1970 and 2020, this pattern of success failed to replicate, but it took people a while to notice. Actually, most programmers still haven't noticed. Yeah, this again could be edited down, but I don't quite know how right now. Oriented programming with many objects that don't know anything concrete about each other is likely to be very slow. But again, it took a long time for people to notice this. Most programmers still haven't. Am I talking about creating millions of objects in garbage collection? I'm talking about anything. I'm not talking about garbage collection. I'm talking about chasing pointers. We explain this later on, I think. Computers are very different than they were in 1970. Now they have tremendously fast CPUs and huge amounts of available memory. Which on a CPU that could do multiple instructions means the lost opportunity to do a couple of thousand basic operations. It is very, very common for programs to stall for thousands of operations. Just another value of one integer in memory. Just to read the value of one integer from memory, let's say. Cross-cutting concerns seem even more persuasive than performance. We're talking about fucking memory allocation in this file, okay? Read. Memory management. We're talking about memory management. Okay. Expend heroic effort to predict which memory your program will want in advance so that it can have that memory in a fast cache before you need it. When this prediction succeeds, your program blazes along. Is largely determined by the degree to which they do not miss the cache. Try to read memory that the CPU didn't know in advance that they would want. This is very different from the olden days, and the number of instructions that are executed determine the speed of the program. By computer school, by Lisp. Step A takes a long time because number 2 is not. Step B then takes a long time because number 3 was not in the cache. Let's say in the cache. Or the problem is there's no way to know in advance which memory to fetch number 3. It depends after all on the pointer of number 2, which will take time to retrieve. We don't know we want number 2 until we decide to follow it. Okay. Okay. This was pretty long, what we wrote the other day. I didn't remember it being this long, but that's good. It means we got through a lot of this. Okay, I should recap this. So, one of the ideas that underlies most modern programming languages is the programmer shouldn't have to manually manage memory. The runtime system can do this automatically, freeing the programmer's mind to do more important things. We have seen that this can be extremely costly, especially extremely costly on modern computers. And furthermore, and often this expense is invisible to the programmer. The performance no longer maps cleanly to an equivalent assembly program like it did in 1970. Something like that, right? Okay, most modern languages are built around this idea that the programmer should not have to worry about memory allocation, and that the task of allocation should be hidden. Oh. These modern languages have different ideas. Mostly agree that memory allocation, that memory should be automatically managed by the system, but they have different ideas about how this should happen. Which is a way of I don't know what to say about this. It's a way of I mean, I could describe, see, the thing is, I could certainly describe this on its own. It's just in the context of what I'm trying to say here. It's hard to describe it in a way that doesn't, like, maybe get us off the subject a little bit. All you see is words from the word God. Okay, so Casey, we're going to get to the code eventually. There's going to be a small amount of code in this file. But what I'm trying to do is, and this is, I'm sure you can imagine this is very hard. I'm trying to explain to people who use this language that the underlying assumption about memory management that is barely even questioned by all languages made, or not all languages, but by most languages made between 1990 and 2020, that all those people are smoking crack, right? And I'm trying to be brief about it, but I'm also trying to explain the basic thing, because we're trying to explain, okay, here are the patterns of memory management that this programming language was designed to enable or facilitate, right? And they're not garbage collection. And here's why. So I'm saying why. That's what we're doing. I'm trying to say that all these people were educated stupid and cannot compute a time cube. Okay? They do not understand the simultaneous 4-day rotation. Smart people working on the language definitely think about memory management, so you don't have to. That is false. What really happens is either you're not really a professional programmer, in which case that's fine. Like, you shouldn't use the same languages that professional programmers do. Like, if you're just a scientist and you just want to try to make some stuff work, you shouldn't be using the same thing that somebody writes an operating system in. That said, you also shouldn't be using Python, because Python sucks for a lot of basic reasons. But that's a different case, right? But like, if you think you're trying to write actual applications that are interactive and respond nicely to a user, it's absolutely false that you don't have to think about memory. Completely false. And you're just, if you're lying to yourself about that fact, then you're just volunteering to not be a top programmer. Like, I don't know how else to say it. There are other good reasons to hate those ways of thinking about memory besides just performance. I don't think, no, because if you talk about cross-cutting concerns, that's not so much about memory. That's about code logic interactions, right? Which I agree, cross-cutting concerns is a good reason to not be object-oriented. But that's not what we're talking about here. We're talking about memory here. And what, like, the thing, again, it's so simple. Like, I almost wish I could say this in 1/10 of the size, because when you understand the idea, it's so simple, and yet almost no programmer understands this. It's like they've all been fucking brainwashed, right? Like, look, on modern architectures, if you think of your program as a bunch of separate things that could live anywhere in memory, your program is going to naturally be slow. Period. I don't care if you're a functional programmer and you're cranking out Lisp lists and doing mapcar all over the place, or if you're a C++ programmer, or if you're a Swift programmer and you've got like Arc on everything. All of those things are going to be slow because you're conceptualizing your data as a bunch of independent things living all over memory. And that is the absolute slowest thing to do on modern processors, right? Very simple idea. Nobody wants to understand this idea because they're bad at programming. I don't know. I don't know what the, like, it's so frustrating. Nobody even wants to understand that idea. Your current opinion is that nearly 100% of modern programming practices are both slower and harder to use, but people don't realize it. Yeah, I mean, so kind of what I'm trying to do. So this file that I'm working on right now, it's by far the most verbose in English, right? But it's a set of examples when you download the compiler of how to use the language, right? Because, so first of all, you know, most systems and languages have terrible documentation, right? But secondly, often when they think they have good documentation, they give you like a reference manual or whatever, right? I want to see your programming language reference manual. What I want to see is, how do I do things in this language, right? Like how do I do the things that I want to do? And so I'm starting with small examples and building up to bigger examples, but they're also trying to give good coverage of the feature set and explain why that feature set and why not the C# feature set, right? Why is it this and not that? And so I think there's going to be a large number of these rants in there, and so I hope collectively they can give a big picture of why these programming models are so broken. But again, nobody like wants to believe it, right? I don't like, everybody wants to think they're a smart programmer, and it's honestly, it's so shocking to me how unproductive modern programmers are, but nobody wants to believe that they're unproductive. It's really weird. I don't know. And well, the weirdest thing about all this is all these giant internet companies that pay so much money in salaries, that if they could actually have the productivity of programmers from 1990, let's say, if they could turn the clock back 30 years in terms of programmer productivity, I mean, their salary expenses would go down to like at least 20% of what they are now, if not drastically even less than that. So it's just very weird. It's very, like, I don't understand. Like, we're living in a giant hallucination when it comes to programming. How about memory management like C++ inheritance, where there's a main data that is the daddy data, and then you have dependent data on it that shares lifetime? Like I said, go back to what I just said. If you think of your program as a bunch of individual objects that live independently or in pairs or whatever, that's a slow program. It doesn't matter why you conceptualize them as living independently. If they live independently, it's a slow program. The end. It's just not hard to understand. The way of sprinkling atomic increments and decrements. Yeah, what I was trying to say is, like, it's sort of like automated reference counting is sort of a way of amortizing garbage collection cost across your program in a more predictable way, except that's not even true, because reference counting came before general garbage collection historically, right? Because it's much simpler. I mean, arc just means it's built into the programming language semantics, right? But like, reference counting is a really old and simple concept, right? Which is a way of let's just say, which stores a number on every node. I'll just put a very factual description. Freeing the memory when the number reaches 0. That's also an oversimplification, but whatever. People will know. The language they use doesn't empower them in trying to achieve that. Instead, it promotes bad behaviors. I mean, dude, web dudes change programming languages every 6 months. So I don't think it's the language. You know what I mean? Like, web dudes change programming languages about as often as they change their underwear, which is every 6 months, which is very frequently to change programming languages. Most languages make horrible code very easy. Yeah, that's a thing that I want to make. By the end of this is like going with the grain, C++, new, etc., Lisp, mapcar, right? Um, so we are trying to make a grain that, if you go with it, results in code that isn't pathologically slow. Yeah, that's the general idea behind the language design. Any suggested reading to learn things from first principles? I don't exactly know. Like, I don't read a lot of programming books. Um, I mean, that's just, when you've been programming as long as me, that's not really something that you do, especially when most of them are bad, like they are. So I don't have good recommendations. There might be some. Um, but honestly, if you just learn about a couple of things, right? Learn about how the CPU works with regard to the cache, right? And like the kind of thing that I'm writing about here, about waiting for values to come in from the cache, learn that a little better. And then, because threading is the future, learn what happens when data is contended by multiple cores on current architectures. And if you know those things, then you have a basis for making decisions about programs that will run well. You know what I mean? Now, the problem is all these ideas about how to program date back to, like, C++ is just trying to do, like, Simula or whatever on top of C, which, again, it's just the wrong thing. Like, all these ideas are 50 years old and computers have changed, and the ideas were not that great before. They're even worse now that we're running on different computers than the ones on which these ideas were had. Do I know Uncle Bob? Nope, I don't. Yeah, somebody linked me this, what every programmer should know about memory, but I haven't actually read it. I was going to take today and just relax and read and take a day off. And as usually happens, I started skimming to page 2 and then I did something else. Or page 3. And then I did something else. So you find it hard to believe that 99% of programmers are doing it wrong. 99% of people in any field doing it wrong would result in catastrophe. I don't think so. I think it's pretty clear. If you know any particular field, absolutely 99% of people are doing it wrong. Take journalism. Take being a state senator. There's 100 of those, so it's very easy to do percentages. What percentage of state senators do you think are being awesome state senators? The more you know about any particular field, the more clear it will be that most of the people in that field do not know what they're doing. Okay, let's get back to the file. We want to get to the new part and extend the file. And actually, honestly, with programmers, it's more than 99% are bad. Like, saying that only 99% of programmers are bad is pretty conservative because the field has just exploded tremendously. And most of these people, they just have no idea. They just. Explain to me what all these strings. Okay, so this is supposed to be an array of structs. All right. This is just supposed to be like a box with 3 things in it. Like, okay. Let me get to this part. They encourage you to think of your data as a bunch of separate. That is exactly the slowest thing you can do today in the year 2020. But this is the way most people, they don't even think twice about it. If that's slow, what's fast? One example of an easy thing for your GPU to predict is iteration over some array. Okay, so these are just supposed to be structs. Like, ideally, I would draw them better. But this is a struct with 3 members, right? A float, a string, or an integer. And you're going in a for loop in order. And I'm just trying to say, look, your CPU will predict what you're going to read in that case. And it'll get it into the cache in time. And so this code will be very fast, right? I'm leaving out the question of how big the structs are and whether you're utilizing 100% of the data that comes in. I'm just saying this is very predictable. All right. That looks not a lot like this, but something. The pointers are packed together in an array, but they point at things that are stored sparsely in memory. But this being a modern computer, the actual values you care about, then we can draw in a diagram like this. And if the array contains many elements, their locations in memory could be pathologically more scrambled. I'm going to do a whole pass on rewriting this at some point in the future. Prose here is not great. In 2016, the estimate was around 4 million professional programmers. 1% of that would be 40,000 good programmers. Yeah, I mean, I'm not sure how to guess. Like, I don't have visibility into most programmers, right? But like, let's say you set the bar for good programmer at like 0.1 CarMax or something. Maybe that's too high. Yeah, I don't think there are 40,000 programmers at the 0.1 CarMax level, right? But I don't, like, that's just a guess though, because it's weird because, I mean, I'm certain, I know there are some really good programmers that I don't even know who they are because they like work for some government agency or something, maybe. But can there be 40,000 of those? Yeah, probably not. How many 0.1 CarMax programmers are there? I honestly don't know how to estimate that. I don't know. Like I would have to sit down and think about this for the long time. Like if I stick to an industry that I know, like the games industry, there's at least 3 digits worth, right? There could be 4 digits worth in the game industry. Are there five? Probably not, right? But 4 digits worth of zero point 0.1 Carmack programmers is still 10% of the budget that we set out of 40,000. So maybe it's not that unreasonable if you integrate over all the industries. I don't know, but again, I'm juggling very vague numbers, and it's really easy to just be off by a lot. But also the thing is, again, games are harder than most other things, so you you would expect the best programmers to be in the industries where the hard work is done, because doing the hard work makes you good, right? If you never do difficult programming, you're just not going to advance as a programmer. So even if games had like 10% of the good programmers, or no, sorry, let me rephrase that. Even if games had like 4,000, which it probably doesn't, um, but if it did, then that still doesn't mean that there could be 40,000 in the world. Maybe. Because games is so much harder. I don't know. Casey says, I would say that less than 1% of programmers worldwide know what the cache line size is of the machine they're programming. Well, I mean, I don't usually know that. Like, I just had to look this up a couple days ago. um, but even not knowing that specific, I know what order of magnitude it is, right? And so, you can model the general behavior of your program in your head and write things that aren't crap without knowing that exact number. Then you're definitely right. Yeah, well, no, I had to look up on last stream that it was 64 bytes for most of these CPUs. I did not know that. I would have guessed 128 for some reason. Or 16, because I guess I remember it being 16 from a long time ago. Like were Pentiums 16 or something? Anyway. Are you using performance? God damn it. Okay, I'm just going to... So Zorn code, everybody can look at what you're saying, and I'm going to time you out because it annoys me so goddamn much. Not because you necessarily said anything bad. Oh my God, the Twitch API, I'm tapping on the name. I can't... There's no timeout anymore. There's only block. It's only giving me block. Okay. I'm going to have to use a keyboard API so I can time people out. Anyway, the point is you're doing this internet thing where you show up in the middle of a discussion that's explicitly on a certain topic, and you're like concern trolling. Why doesn't this document address the basket weavers in Afghanistan? And I'm like, look, we're not talking about the basket weavers in Afghanistan. We're talking about memory management. That is what we explicitly came here to do. Okay? Yes, there are other important things in the universe. Shouldn't I be thinking about the fundamental laws of physics in case I make a breakthrough? Yes. But we're talking about memory management. So I don't think I actually banned him, but it says message deleted, so maybe he's banned. I don't actually know. Performance-oriented programming does help fight climate change. It's just, this is what's so bad about the internet, right? Like, okay, the problem with the internet is it encourages short attention span everything, right? Like, we need to we need to develop a culture where everybody knows that you shouldn't walk into the middle of a meeting room of a meeting that's been going on for 3 hours and start commenting 30 seconds after 30 seconds of hearing the last person speak. Or that's just not it. You're not going to say anything intelligent, right? And you're going to derail every conversation. And then if 1,000 people are doing that, it's just awful, right? So like the internet of the future that actually works is A, doesn't encourage that or actively discourages that. B, makes people, this is something I was ranting about yesterday, it makes people take the consequences of uttering an opinion that is incorrect, right? So the reason the internet is so horrible now is because everyone's going, meh, 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 but don't you, ba, 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 all the time. And they're just bullshitting in the sense that it doesn't matter if they're right or wrong, and they don't actually care that much if they're right or wrong, right? And nobody else cares either, and so there's just all this noise. Like, you need to make a Twitter where if you said something and it's wrong, that reflects upon you, right? And then people will shut the hell up about things that they don't know what they're talking about, to some degree. That's what we need to do. Did you demand a demo of the variable? I didn't see that. Look, I've only been working on this programming language for 6 years. I haven't managed to research the variable yet. It'll take a while. How about just ignore them? Okay, you're fucking banned. Like, literally. All right. Anyway, we haven't got to the bottom of the file. We're just talking about how it's inefficient to seek around in memory. Okay. So then I'm coming to the point. Okay, so this actually, it's not just about performance, we said. It actually also makes your code more complicated and harder to understand. Okay, and this is where we left off. So we get to write new things now. So one thing I want to do is talk about like the rule of 3 kind of thing in C++. Except that became like the rule of, how many is the rule now? Is it like the rule of 7 at this point? Rule of 5. This number only will ever go up over time, by the way. Remember, it used to be 3, now it's 5. Can we get some solid in there? So the thing about solid is I skipped all that stuff. So I don't know anything about solid. I guess it's an acronym. Okay, so the problem is when trying to make a black box with everything hidden neatly inside so that the programmer doesn't have to think about resources in any way, like memory, well, it never works out that way. The stuff you are trying to cram into the box never quite fits into the box. You can get pretty close if you are free to choose the shape and weight of the box in order to fit the functionality that goes inside. But the problem with languages like C++ is that they prescribe boxes of uniform shape and weight, and you're supposed to build your program out of those boxes. Maybe I'm getting a little too overgeneralized there. You wanted to just leave that Skype call in the moment. Why didn't you? You'd probably have more self-respect today if you had just hung up the call. I'm not sure if what I typed in this paragraph is a good way to lead into what's coming up. In order to abstract away concerns like memory use, C++ came up with the rule of 3, which says that for every single object you make, every single kind of object you program, you must make at least 3 functions that initialize, that are capable of constructing, copying, and destructing that object. Then C++ got more complicated and it became the rule of 5. Isn't there a rule of 7? 5 or 6. I don't know who's saying that. Or maybe even 7. one thing you'll notice about these modern, one thing you'll notice about these programming paradigms is that the numbers only ever go up. Okay. The numbers only ever go up. Like, the problem is doing a good job explaining this. Okay, what do I want to say? Okay, what are the endpoints that I want to get to? About, okay, I want to say the following. I want to say you have to write all the constructors, destructors, right? Like, it's not magic. Like, the fact that the fact that memory allocation is packed away inside some function that happens to be called the constructor doesn't mean that someone didn't have to write it, and doesn't mean that it's not there in the code, and doesn't mean that it doesn't add complexity to the code, right? So weight of code matters. Understanding means knowing all the code. Anyway, like once you need to pass some level of understanding of like, I guess I would say, like, an abstraction barrier like that, like a constructor, is kind of provisional, right? Like, at some point, you're going to want to look on the other side of that abstraction barrier to understand what your program's doing, either for performance or functionality reasons. And so the more code there is, just the more there is to understand, right? And that when you have to do these rule of 17s, it just means there's a lot more code, right? What else? Are there any other basic points that I want to say here about complexity? The fact that black boxes mean like, a thing that happens when parts of a program don't know about each other is redundant code has to happen, right? Maybe I'll figure out a good way to explain that. Has to happen to make up for the information shortfall. And then again, isn't it just sufficient to say no current CPU architectures do things efficiently one at a time? Memory is no different. You never want to construct or deconstruct simple things at a time or your program will suck. Yeah, it's just I've moved on from the performance part a little bit. Like, section 5 here, I put this performance thing here, but what I'm trying to talk about now is that it's not just performance, but also complexity. Like, and not in the usual object-oriented cross-cutting concerns thing, but I want to try and say, and again, it's a hard point to make because it's a very subtle and particular point, but like just the act of trying to encapsulate in a black box all your memory allocations actually is going to make your program more complicated and slow than it would be if you didn't do that. That's what I'm trying to say right now. Is you end up with a lot more code, right? Okay. Someone has to write those functions. That takes engineering time, and they have to be compiled every time you press the compile button, which takes time. If most of them are not really necessary, you could be saving a significant portion of your compiled time. I don't know if I really want to go into that, but as time goes on and you have more objects, you end up in a weird place where they all seem to be doing where a large percentage of your code seems to be doing bureaucratic things having to do with constructing, copying, and destructing with very little actual work being done. By actual work, I mean some computation that I want to say like that information theoretically brings you closer to the answer to the problem, right? That does not constitute overhead or is not about maintaining the structure of your program, but that directly speaks to the answer you want to output in some way. That's not a very good explanation. Because all these object methods are supposed to treat other objects as black boxes about which they know nothing, you end up in a situation where you aren't allowed to assume things that would make your life easier, but that actually are probably true. So you end up writing a bunch of code. You end up writing a bunch of code that is about pretending that you don't really know what is actually happening. There's probably a better But that's the thing. Okay, it's funny because this kind of delusion happens in both object-oriented and functional programming. In object-oriented programming, you're supposed to pretend like you don't know what's going on and do all this work to pretend like you don't know what's going on. In functional programming, you're supposed to pretend like you're not manipulating state and do all this work to obfuscate the fact that actually ultimately you're manipulating state, right? It's like a similar thing. Structure. Structure. Is it necessary to have a degree to be a game developer? I do not have a degree, so I am probably not a real game developer. I have a high school diploma, I guess. I don't know where it is, but I think graduate from high school. Okay. So, then eventually you have to deal with OOP's misconceptions about what abstractions actually are. Abstraction is good because is often good because it reduces the number of details you need to think about at any given time. But it's really a temporary reprieve in the sense that if you live with a code base long enough, you're going to have enough problems to iron out that you'll need to look behind most of the abstraction barriers eventually. At least to understand what's going on and likely to possibly to change what's in there. If the goal is to understand the entire program to the greatest degree possible, then hiding code behind abstraction layers doesn't make that code go away. You'll still need to understand it eventually. And in fact, in the short term, the pretense that you don't need to understand it now is likely to do a great deal of harm. In the cases where you are wrong. Okay, this is getting a little far from memory. Do you plan to have one global object with shared state? No. How do you plan to create any abstractions? What? Do you not know about any other programming languages that are not object-oriented? There are lots of them. You're acting like I'm suggesting something that nobody's thought of before. That your programming language is. How can you have a programming language that's not object-oriented? I mean, that's not my goal to answer because you just have to look around on the internet a little bit. Okay. You know, this. I actually wonder if I shouldn't instead, in the future, do this kind of thing as a speech and then transcribe it. Because the thing is, I feel like when I explain things verbally, they come out better. Maybe that's just me fooling myself and my speeches are not that good. But like, as I look at these, I'm like, this isn't as convincing as I would like it to be. And it doesn't go into as much detail as I would like it to be and so forth, right? Who knows? I don't know. Let's not go into this more. Okay. The ways in which object-oriented programming becomes complicated are many, and we just can't go into them too deeply here without going too far off the core topic of memory. Similarly, functional languages have their own set of games that they play to pretend you don't need to know about have their own set of games that they play. Let's just leave it there, but we won't get into those at all. But we will skip those for now. The thing is, when I give a speech, though, it is the end result of like 4 days of thinking about what to say. Whereas right now, what we're getting is what I initially think about what to say. But that's the weird thing is, so, you know, when I write a speech, I don't do it like this. I don't like linearly or quasi-linearly put words down. I like put a bunch of notes down. I read through the notes a bunch of times, figure out really what I want to say, and then I say it. And there's like never actually a script for the speech. So for the future things like this that are really long, maybe I'll try it that way once and see how it comes out and see if I like it better. Beta testers ain't worth 4 days. Well, this isn't just for the beta. This is like long-term. Some version of this will go out to everyone who gets the programming language eventually. So okay. If I'm saying all these things are bad, what's good? Good question. Let's start talking about things that are good but we'll have to show they are good by contrasting them with things that are bad. Let's take a typical situation of constructing a binary tree. Because, hey, you might delete a node, insert some other nodes, and so forth. But often, these binary trees have known lifetimes. In the example of the game that will ship with the compiler, we make BSP trees each frame for some of the light beam effects. And we know that we are going to render the geometry from these BSP trees and then be done with it. They won't live past the end of the frame. Right? Okay, so let's get a little bit less roof. We're generating something you'll use and then be done with, right? Okay. To do this the C++ way, you have to make some kind of node class with a constructor, destructor, copy constructor, and whatever other methods are required. Then, when building the tree, you new each node on the heap separately, point them at each other, when a node is removed from the tree, comma, when a node is removed from the tree, its destructor will recursively delete its children, which is a pretty slow thing to do. All right, which is let's say that's very slow, right? That is very slow. But if you know a little bit about how the tree will be used, you can design something much simpler. For example, for our single frame BSP tree example, we know that after we have drawn the geometry to the screen, we don't need any of the nodes in the tree anymore, right? We also know that the individual nodes don't hold any file handles or other weird resources. They are just holding straightforward geometry data and pointing at each other. So when it comes time to reclaim the memory for the tree, we can just reclaim the entire tree at once without recursively destructing a bunch of nodes. How? Well, you use an allocation strategy that allows you to do this. If everything related to the tree is stored in the same memory arena, you just reset the arena to the empty state, which is so fast it's basically free, regardless of the size of the tree that's in there. Right? As a bonus, because we know we will never need to free individual nodes from the tree, the nodes can be allocated much more quickly, can be allocated so quickly it's almost free, and they can be packed together more tightly, more efficiently in memory, which means our cache utilization will be better. Okay, but I just placed a constraint that we can't free nodes until the end of the frame. What if we need to remove a node from the tree in the middle? Some nodes, let's just say some, processing the geometry. It's no big deal. We don't bother to deallocate them in any way. We just forget them as though we were using a garbage collected language. Because the entire heap is going away at the end, of the operation, we just don't have to worry. Yes, our amount of memory use during the interim time will be slightly higher because we didn't free this thing, but if you take into account all the overheads required to run an efficient, randomly allocating heap that can, an efficient heap that reuses deallocated memory, you'll find that for most applications, that for many, let's just say many, not getting into an argument, for many applications, we still come out ahead. Okay. Should I start typing code here? Is designed to support this kind of bulk memory operation as the default. It doesn't help you very much if you want to do the recursive node destruct thing. This language does not have destructors at all, and as for initializing nodes, we don't have constructors, just things that can initialize members to constant values without running arbitrary code. By supporting bulk memory operations as standard conventions, we allow authors of libraries of subroutines of your program or of libraries written externally, libraries written by people you don't know. That's a very don't know to use these conventions in a coordinated fashion. What about memory fragmentation? Yeah, okay. So woof woof dude, you're imagining, okay, there's sort of a weird mistake in the C and C++ memory model, right? Where they imagine that there's this thing called the heap, which is like all the things that could possibly be dynamically allocated, and that when you call malloc or new, there's just something on the heap, right? And there's no way to organize it. I should probably go into this right here because it's a misconception that a lot of people have. That is actually just an arbitrary distinction on the part of C or C++ or whatever, right? And it's not a very good way to program. You don't really want an arbitrary heap that holds all the memory for your program, because you can't classify that into different ways, right? So when I'm saying here, free the whole tree at once, what I'm saying is you make a separate heap just for that tree. All the memory for the tree is in that heap, right? It is not the global heap. It's its own heap. And then you just clear that heap when you're done, right? It's actually very simple if you understand that a heap isn't magic. It's just a data structure. But a lot of people don't know that. You're thinking I'm talking about the node delete case. Because heaps aren't magic, guys. Heaps, or let's even just say allocators, right? Because a heap is sort of a specific kind. They're not magic. They're just some memory and then some way of making decisions about how to give the memory out, right? If you imagine one that just returns, if you say allocate 16 bytes, it just gives you the next 16 bytes and then moves the pointer forward. That's a very fast allocator, and then it just doesn't have the ability to free anything, right? But that's fine because you're going to free everything in bulk at the end. So what does that mean? It just means setting the next memory pointer back to the beginning. And maybe if you have like how much space is left, you set that back to the maximum amount or whatever, right? That's it. That's a super fast operation. You don't have to free the memory inside, right? This is the problem with the object mindset, is that you're thinking about some object that you allocated as being like a physical thing that has to be deallocated. It doesn't, right? It just lives in some universe, and you're pushing the disintegrator beam on the whole universe, okay? So the whole universe instantaneously dematerializes to nothing at the cost of very few CPU cycles. You don't have to go in there with a hammer and hit all the individual objects. That's the whole point. Does that make sense? Do people get what I'm saying? I mean, I could put a code example in here, but this is actually one specific thing, and this file is supposed to be maybe about the set of several things together. Talking about deleting nodes mid-frame. I just said that. I just said what if we need to remove some nodes in the middle of processing the geometry? We just forget them, is what I say. You don't actually deallocate them, right? So, okay, so I guess what you're saying is, if I'm not actually using these nodes in the result, don't they live inside the used memory and sort of de facto act as fragmentation? And the answer is yes, but you're probably not going to do better than that by trying to dynamically repack the memory. It's probably almost impossible. I mean, that said, that does sort of depend on your application domain as well. And there are always specialized things. So if you knew that you only ever wanted to allocate these nodes out of this heap, right, then you can use a data structure that treats them as a bunch of interchangeable slots, and then you can free them, because if you've just got an array of things that are all the same size, freeing those is very cheap as well. And then you could put your next node in that slot, right? Here I'm talking about a more general case where, you know, maybe you're putting arrays and strings and whatever all in this same heap. Okay. It's the Star Destroyer versus Star Trooper approach. I guess so. Of memory use. Extremely short-term use. We need to allocate something, but we'll be done with it by the end of this function. Short-term use. Let's give these our program might need to use this memory at various times, this computed result at various times, but there is a clear time by which there is a clear moment in the program when its lifetime is known to be over. For example, the end of the main loop in an interactive program. 3. Long-term use with well-defined ownership. We don't know when this memory can be freed, but it all belongs to the same computed result or is owned by the same subsystem, and none is shared with anyone else, so perhaps freeing it can be very fast and easy when the time comes. 4. Long-term use with poorly defined ownership. Different portions of the program will choose to manually deallocate these things at different times. Portions of this data at different times, so the data probably has to be separately allocated and separately deallocated as you would be used to from C++. Most C++ programmers pretend that all scenarios fall into category 4, but actually, in a well-written program, category 4 is very rare. In fact, you might treat instances of category 4 as indicators of a probable design flaw, and that if you clean them up, maybe your program will become simpler and easier to maintain. Debug and maintain, right? Does that strike people as a reasonable classification? But you can make a bump allocator that implements the standard allocator functions and use it as a template argument to your tree. It's annoying and convoluted, but a solved problem. No, but the point is the annoyance and convolution. All right, I'm still going to get to that part. But the point is, whoever wrote the code for the tree had to write all these frickin' destructors and stuff. And usually you don't have to do that, is part of the point. Sorry, I'm behind on chat. You think I'm being too judgy with most C++ programmers? Dude, most C++ programmers like write business to business applications for like doing something overly complicated for like tracking shipping to your warehouse or whatever the fuck. Like look at what the talks at CPPCon are about, right? That's what I'm saying. How can you write things so it doesn't become for? Well, step one is just to understand that these other cases exist and look for them. And I think as soon as you start looking for them, you will find them. Okay, Casey, since you probably think about this in a practical sense more than anyone else in chat, what do you think of this 4-category breakdown? Is it a reasonable breakdown? Am I missing something important? Casey says, give him a moment to chew grass in his 4 stomachs. Okay. Okay. Yeah, examples of each of these cases would be good. But before I do examples of the 4 cases, I want to know if Casey thinks other cases would be better. How would you go about turning a 4 into a 3? Well, it depends. It depends on the specific case. Like, I think often like it might be something like, oh, there's some strings inside this data that we pass that other people want to use. And you could just copy those out, right? So that when those people get those strings, they copy it manually, but then they actually know that they own the memory, right? And like it just makes these things clearer. But, you know, Isn't one just a stack allocated variable? Not necessarily, because it's dynamically sized. So that would be like alloc A in C++, or like, dude, C++ programmers don't use Alloca. They don't know what the hell that is. Did I design a language with this categorization in mind? Not strictly. It's not how you think about it, but you do think it's good. The difference in your mind is you don't really think of it as categories. I think of it as two separate things: lifetime of the group and lifetime of the element. Yeah, I mean, I never. Oh, does C++ not support alloc anymore? Are you shitting me? Now, it does support arrays where the size of the array is variable. I know that. It was good, so they got rid of it. Memory that's never intended to be freed at all. Okay, that's a good point. Let's make that 0. Well, no, I don't want to. I agree that that's important. Like, if you can represent something as static data, you absolutely should do that, right? Or if it's dynamically allocated and then never freed. Let's say that up here. If at all possible and fastest to use, statically allocated data, or data that once initialized is never intended to be freed. But if you do want to use data with dynamic lifetimes, you can think of them as falling into one of the following 4 categories. Okay, so I bring up static stuff before all the dynamic things, because we sort of got this ramp of increasing mess from 1 to 2 to 3 to 4, right? Deprecated, bro. Pretend that all scenarios fall into category. Okay, C++'s design. C++'s feature set pretends that all memory allocations fall into category 4. So most C++ programmers have to do the amount of programming required to support category 4, when really they could be doing much less work, because actually in a well-written program, category 4 is very rare. Sure. Yeah, pretends is not quite the right word. C++'s feature set suffers from the mistaken idea something like that. Okay. Yeah, it does that because it tries to be one size fits all, but in the process of being one size fits all, it drops you down to the worst size. Like, look, when I go to the clothing store, I don't want to buy one size fits all clothing. I want to buy the clothing that fits on my size. You can write standard C++11 to create memory arenas. You just create an allocator. And did I mean something else? I meant all the stuff we've been talking about for the past hour about how the entire programming language is built around constructors and destructors. Like I don't think what I'm saying here is hard to understand unless you're willfully misunderstanding it. I don't feel like there can be much legitimate confusion around this. Rust or bust for game dev? I have a whole video on YouTube about that. What category would that be for memory for a game script that allocates on simulation start and freeze on end? Um, that would probably be 3, right? Or actually, it would probably be sort of 2, right? I mean, provided that you know when the simulation ends, right? If it's like the simulation is running in a thread and the script that's running threaded decides when it ends, and in that thread it frees all of itself, that's probably bad design, right? Your main program should probably notice when it's done and then free it. But I would put that in category 2 if well designed, or maybe 3 or 4 if poorly designed, depending on how bad it is. Did I address the comment that suggested local function variables from C++ which go on the stack are the same as 1? Yes, because those are not dynamically sized. 1 is dynamically sized. Okay. So I think I did a how-to about temporary allocator, and I can refer people to that, right? Um, didn't I? Maybe I didn't. I didn't. I did a demo about it. All right, well, that's gonna... Oh, no, I did. 012, temporary storage. I'm blind. So this one, we already talked about early, actually, which is good because we get people used to this simple concept, right? Okay. Category 1 above would be handled with something like Alloca from C. This language will eventually support Alloca, but it doesn't currently. Right now, we mostly treat categories 1 and 2 as the same thing. You can use temporary storage for most cases of this. You can see how that works in 012 temporary storage, but to summarize if you want to dynamically create a file name of unknown length from input strings and use it, you can just pop off something like this. Open file, tprint, user local percent, Sailorville, game save whatever dot sav, right? Right, username and save index. We don't have to worry about the result of the string at all, about managing the memory of the string at all. Tprint creates a result in temporary storage, which will be automatically reclaimed later. This is the same convenience you get from a garbage collected language, except it's tremendously faster and actually more convenient because you know the exact lifetime of the string. Because the exact lifetime of the string is explicit. Okay, does that make sense to people? Yeah, that temporary storage video is still on YouTube, so anyone who wants a video intro and wants to check it out, there you go. Because everyone knows about temporary storage, including libraries you may use. The author of a library can just return results like this without having to program any destructors or what other memory management infrastructure, so long as the use case is suitable for temporary storage. Okay. B plus parentheses is an emoji. That's great. That's great. Okay. Casey is not on the beta test of this programming language. And the reason why is because I don't want to bother him while he does his 17,000 projects. Is this going to be a book or an article? Is it available to read online? Well, this is going in with the code examples. The further we get through this one, the more I'm starting to doubt that there might be any code in this one. We'll see. I mean, it might get put into a book or something like that longer term. Who knows? It'll be available online as soon as the programming language beta is available online, or maybe before that. Like, I could see putting these up for public consumption before the open beta, just for people who are curious about it. The problem is just like, because web is so terrible, our websites are like decaying all the time, and I don't have anybody working on that right now, and so I don't want anything else on the web that that is not the absolute minimum right now, because apparently you need a full-time person just to keep a website from going down, and we don't have that right now. Is temporary storage limited? No, not really. Well, maybe. But in a safer capacity than Alloca? No. Why are you saying safer capacity than Alloca? You're making that up. How does temporary storage know when main loop ends? It doesn't. You do. You call reset temporary storage when your main loop ends. You'll be my full-time website guy. Look, I have, I think, 3 times now hired people to do contract jobs on the websites from either Twitter or Twitch chat. It's been a complete disaster every time, of people who just like, it was terrible. I will never do it again. It was so bad. So much Dunning-Kruger. It was crazy, dude. On Twitter, there was someone who was like, the witness website is down, and you said, do you know why? And I totally wanted to hear why. The reason why is because websites that are, like, what is the witness website in principle? It is largely static content, right? With a little bit of ability to post messages, which, by the way, doesn't work right now. Why did it break? I don't know. Because some combination of security updates plus WordPress updates, which you have to do all the time if you don't want to get completely owned, like, broke it at some point. Why? We didn't change anything, right? I just want those changes to be on the web, like, permanently. But now I just have to stop and, like, do research into why our fucking website stopped working. And that's going to take probably a week to fit. Like, you know, the solution is probably to move it to a new machine at this point anyway. Like, the reason why the website is down is because the web is so bad that you can't really post static content even anymore. I mean, maybe if we had done that with, what's it called? But yeah, the whole point is like, look, I'm kind of busy doing real work right now. We don't have anyone whose job it is to fix that stuff. And don't really want to stop. I have way too much work to do. And I don't want to stop doing that work because web dudes are bad at their job, right? Like, it's just Ruby on Rails is the answer. Why not use Hugo? Because it's a lot harder for, well, we tried to switch to Hugo, and then the person who was going to do that, like, didn't really set it up right. And again, I have to now go start figuring out where that was left off and like try to pick it up. But the other reason is that for content people, it's not a very good interface. And it's also a little bit of a security risk in some way because, well, I guess depending on how it's set up, maybe more, maybe less. And then also we wanted to have comments anyway, and apparently that's an unsolved problem in computer science. Unless you have a third-party service like Disqus that owns all the content comment. Like, it's just terrible. It's absurdly, embarrassingly bad. Since when is Markdown not a good interface? When there are people who want to know what the thing looks like. Maybe I can answer this from the chat, but you were explaining that there's no actual reason why temporary allocations can't just actually happen using the same stack as everything else. But people who write compilers don't think stack allocations are good, so we never get any compilers that actually support a unified function large data stack. So do you mean having a second ancillary stack that's different from the one that holds your procedure arguments, right? I mean, okay, so saying ancillary stack is weird because that's a specific term now too, right? So there's the kind of ancillary stack that's the security kind where it's like, look, only our program counters and like maybe calling convention register. I forget exactly what goes on the main stack, but like just secure shit goes on the main stack. And then the ancillary stack is like all your local variables and stuff, right? So do you mean along with the local variable stack or like a totally separate? I think you mean like a third stack, right? You just mean you can do alloca 1 gigabyte. There's no reason you can't just have a real stack allocator that is the only stack. I see. So you mean do you mean having a function that you could like pass to other functions that want an allocator and it screws around with your own stack pointer and so forth, and then you just make sure you undo that before returning? Is that what you mean? It's purely because the stack is this old school implementation for no reason. It always bothers me that the stack goes negative. Like, I of course know why that was done initially, but like, why do we still do that? Why does the stack pointer go down every time? Can somebody please change that? If you use Alloca, you can't actually allocate anything large. Oh, I see. That's just because, so there's this thing, we actually have a routine to do this in the compiler, right? Like, if you have a large stack frame, you're supposed to do like this probing thing because the operating system maybe didn't really make those pages or whatever. But yeah, if you just did that, I don't see why you couldn't alloca something large. You don't understand why somebody would use WordPress. It's like a third-party game engine. Because I spend my entire life making the game engine right now. I don't have another life to make a website. In fact, I barely get to design games because I'm making a programming language and running a company. I'm a much worse game designer than I would be if I spent all my time designing games. So if you think I should also be building websites, then go to somebody else's stream, because I don't have any tolerance for this at this point. Do not tell me that I don't do enough work, because I will punch you if I ever meet you. All right. Oh my God, the things some people say. Not really, right? Like, I'm not gonna, for people on the internet who take everything too literally, I'm not really gonna go punch somebody over the fact that they said that I should make a website. But like, dude, I'm tired. I'm here till midnight every night just streaming with you guys just to get a little more work done than I would have during the day, right? Like, I only can do so much. Okay? At some point, it is somebody else in society's responsibility that they did such a bad job at something that I can't even use it reliably, okay? Like, if the astronauts get in the spaceship and it's going to go land on the moon and it explodes halfway to the moon, you don't say, well, everybody knows spaceships are dangerous. The astronauts should have built the hull themselves so that they would know that the spaceship was safe. That's just not, you can't have a society that way. You need to be able to rely on other people to do their jobs well. And the problem in software is, like we were saying, almost nobody does a good job. And in fact, we've institutionalized doing a bad job as what we call programming. Think about that one. Remember experimenting on a Raspberry Pi kernel, and if the ISA allows you to make the stack go up instead of down. Couldn't find a way to get the C compiler to do that. They just said don't do that. Yeah, I don't know. I feel like it would be easier to debug if the stack just went up. Like, come on, guys. It's 64-bit. Just make the stack go up, please. Please. The rocket blew up because they didn't switch to Git. Well, it's not like switching to Git would be good, because Git obviously doesn't do the job well anyway, so they would have to program their own Git before getting in the rocket. Isn't this a legacy thing from when we just had 64K? Yeah, I mean, it was basically, it's from before virtual memory, right? It was like, look, we've got a stack and a heap, and to maximize the size that each of them can be, one starts at the bottom and goes up, and one starts at the top and goes down. Now, the really annoying part is because heaps are unordered, it would have been better to make heaps go down, because of a generalized like malloc heap, nobody's really counting the addresses or thinking about the order. But the stack going up is something you think about while you're programming. So it would have been better to swap those around in the first place. If you had to have one go down, have the heap go down. And then we could have just invisibly fixed that and it would have been fine. But someone decided to make the stack go down, and that was a disaster. Isn't it because other programs use memory? No, this convention goes back to before there were other programs on the machine. This convention goes back to you only run one program at a time. Is streaming conducive to productive work? Sometimes, but often not. Often it's conducive to me saying stupid things. Stack going down makes sense to you? All right. Whatever, dude. Would I recommend learning Emacs in 2020? No, I would not. Middle out stack. What if you tried every other editor and disliked them? Then sure. How would I like OpenGL to be? I don't ever want to use OpenGL again. I don't think it's a good API. I would prefer to just draw all the pixels in software. That's too hard right now because it's too slow. In the long term, when we have ray tracing, I don't know. I don't know, man. Hard to say. You've debugged raw stacks so much that your conceptual model of memory also goes backwards. Well, great. It's how the new Unreal Engine works. You mean the raycasting part, or what? Or them drawing all the pixels? Do they actually software render? No. Oh, and a compute shader. Right. So the question is just, are compute shaders on GPUs going to be faster at traversing data structures that are good for holding geometry, that are still at least kind of convenient? Like, just like with memory allocation, you want to do the work required to make the data structures efficient for the job, but you don't want to have to do crazy amounts of stuff like on PlayStation 3 or something, or even 2, where you have to make them pathological for reasons that aren't good. So I guess the question is the GPU going to be better than like an AMD CPU? Like at running compute shaders, if compute shaders are the only thing, right? Like, does NVIDIA make a lot of money because their hardware is so good at per pixel right now? Or can AMD take that back? And I don't know. I don't know enough about like current ray casting data structures. Unless AMD puts tensor ops in their CPUs, NV will continue to crush it in the AI space. I mean, you have to look at what's going on in AI right now as a very temporary situation. Dude, I'm not even hungry, and I'm eating so many of these, and they don't even taste good. It's Casey's fault, because he sent me a message earlier today that if I get really fat, I will never get a disease. So that's why I'm eating so many of these chips. These are buffalo wing deli style pretzel chips, which sure sounds nutritious to me. Now, to be fair, if anyone ever accuses Casey of fat shaming and tries to cancel him, I can bust out that message and say, no, it's the opposite. Casey tries to make all his friends fat. So Casey, when somebody tries to appoint you to the Supreme Court, that text is going to come out in your defense. That'll be really entertaining, watching Casey's confirmation hearings. What's the most infuriating thing about OpenGL? The most infuriating thing about OpenGL is that the people... So first of all, the drivers are doing all the logic and you can't see into the drivers, A. And B, the people who wrote the drivers are a lot like current people running for president in that they don't give a fuck about you at all and don't care how hard of a time you have and make your life needlessly painful. That is what I don't like about OpenGL. This is insulting to our current politicians. I mean, no, I don't think it's insulting to our current politicians. I think it's pretty obvious. They'll all say they care about you, but look at the decisions they make, right? I mean, come on, bro. Sounds like I'm voting for Joe Jorgensen. No, I am voting for chilling on my birthday and eating a lot of chocolate. That's what I'm voting for. Have I done video about the way the witness does whatever rendering optimizations it does to manage the large seamless world? I don't think so. That's how you feel about Vulkan, and that's supposed to be less driver overhead. Yeah, I mean, it probably is less driver overhead, but it's the same attitude. It's the same people writing the drivers. What graphics API would I recommend learning first? I don't know. SDL something. I don't know. Doesn't matter. All right, good night, Casey. I'm probably going to go to bed soon, too. We're not getting a lot of writing done. I am getting a lot of water spilled on myself, though. The witness does a nuts quantity of draw calls. I mean, it's like 6,000 or something, right? Is inline assembler possible? It is not possible currently. At some point we would like to do it, but we don't support it right now. All right. Okay. What do I want to say about the case 3? Am I open to releasing this message publicly? Yep, just said that 20 minutes ago or whatever before saying I would punch someone. Why is inline assembler hard? It's just a lot of work. Like, there's just really a lot of assembly instructions is what it comes down to. If you don't know how many there are, just take a look sometime. There's just so many now. So many. It was doing like up to 11K. An engine like Unity can't handle half that. Well, yeah, I mean that's the advantage of making your own code, right? It can go faster. It can do things that are more specific to what you want to do. It can optimize for your situation. Will we support ARM? Yeah. We have not modified the language syntax in major ways yet. That is still in the future. Yeah, the thing about the witness is, 11,000 or six, let's say 6,000 draw calls. It sounds like a lot, but it's not that many because let's say you've got shadows and you want to draw all those things into shadows. And then you've got water and you want to draw things into water. So that's like 3 passes for, well, in the unoptimized case, 3 passes for all your geometry. So that's like 2,000 per pass to get 6,000, right? So like, can you do your whole world in 2,000 draw calls? Maybe not. Maybe not. That said, I think if we went back and like really tried to optimize the number of draw calls, we could get it way down as well. But we worked hard on that game for a long time. We had a limited amount of time to do it, and we did what we could do. Public beta will have new syntax? I don't know. I don't know what the new syntax will look like, so it's hard to speculate at all. I don't know if it'll be that different. Like, there's the option to do new syntax, but unless we actually come up with something that is clearly better, I wouldn't change it, right? And so what has to happen is we just look at it and try to figure out what is clearly better. Okay. For longer term like case 3, we provide some other options. There's the pool module distributed with the compiler, which gives you a very fast allocating memory arena. This module gives you a function of type allocator that can be used on any data structure or in any procedure type allocator, which is a standard type, or in any procedure that expects it. What else do we say about that? Probably nothing. Probably nothing. You know, okay. Furthermore, the context data structure, which gets passed implicitly to all procedures, contains an allocator, contains a default allocator that you can override at any time. When any code, including code written by people you do not know, calls alloc, alloc calls the default did I call it something else? Calls the alloc calls context.allocator to actually get the memory. So unlike C or C++, where replacing malloc is a painful link time operation, here it's dynamic and can be done cheaply at runtime as often as you want. This means if someone made a library that creates trees, you can just push a local allocator, call into that code, and when it's done, that code doesn't, oh wait, and when it's done, you use the result, then free all the memory in bulk as discussed above. If the author of the library expects you to do this, let's say he, because I was about to type something that will get me accused of saying women are lazy on Twitter, right? So I'm going to put a man here. He can get away with doing a lot less work. He can just leak all his memory but it's fine because you will deallocate all of it in bulk. So you got to know when to use what pronouns, all right? All right? Okay, what else? Does the context have calls to push pop allocators? No, you do that manually. Well, actually, what happens is you can make a new context, right? And then you actually push the whole context and do a block of code. And then when the block of code exits, that context gets popped, right? That's how that works typically. When you use this philosophy on your own code, you'll find that you can okay, let's just break this into a new section. 8. But isn't it complicated to have to think about all these different categories of allocation, like 1 to 4 above? Doesn't it make programming more complicated? Actually, no. For several reasons. Firstly, apply the bulk deallocation strategy to your own code. You'll just end up with a lot less code, and this gives you less to think about in the long run. And because your code will run faster naturally, you don't have to think as much about how to make it run fast. Okay, what was my other reason that I was going to say? I know I had another one. Oh, yeah. Also, having a clear idea about the lifetimes of data and making these lifetimes explicit in your program. To some degree. I mean, this is where it gets it's not even about making them explicit. It's about factoring your program so that the data have clear lifetimes, i.e. fall into categories 1 to 3 instead of 4, will usually result in a program that's easier to understand and maintain. I'm trying to think. I'm pretty sure I had a third reason here. How many chapters start with the word but? Every chapter. Reduces coupling. It does kind of do that. Well, actually, let me say, lastly, knowing the actual requirements of the API you're using, knowing the actual resource requirements of the API you're using is often a good idea. Because that's how you build a higher quality experience for your user. If a procedure call can open a file and store the file handle in an object, that's a good clue that this call may block for more time than you'd like, and you shouldn't call it from the main thread of an interactive application. If everything is a black box and you don't know and is allowed to do, and you aren't allowed to know what anything does, then you sort of have to preemptively over-defend against things that may happen, but in reality can't. I don't know. That last part of that I don't feel is a very good explanation. I actually, before I started talking about files here, I had some other idea vaguely at the tip of my mind that I'm now not remembering. Oh. Okay. But lastly, and perhaps more importantly, is the way the human mind works. I actually want to steal the last point from the previous paragraph. Yeah, I'm going to delete the third part. We find it easy to think about concrete things and harder to think about vague, abstract, uncertain things. This is a reality that has not been publicly acknowledged by computer science educational institutions or by the best practices espoused by industry. If you know exactly what code is supposed to be doing, including what the resource requirements look like, you can form a clear picture of this in your mind and see what's a good idea usage-wise. On the other hand, if everything is a vague, fuzzy black box, you can't reason about very much at all, and you have to preemptively over-defend against all sorts of situations that in reality can't happen, but you don't know this. Or do all kinds of redundant work that is unnecessary. This is one of the reasons that modern software is so very huge, lines of code wise. Right? Well, there's that too. I could have said that, but I did not. Okay, that might be where we end this stream because it's like 1 a.m. and I'm starting to get a little tired. I was hoping to get to the end of this document. We're pretty far though. We got some stuff done. Right? We started around here at 5. Okay, I felt like we were kind of slacking for a while, but wait, where's 5? So the end here is at line 505 down on the bottom there, and we started at 274. So we didn't quite do. Oh wait, at 270. So we did about half the file. A little less. But we also reviewed the beginning instead of just writing the whole time, so that's good. Remember to delete the third paragraph? I thought I did. Oh no, I didn't. Oh no, that's some of the lines I just counted. It's fine. Okay, so I don't know if I'm going to finish this on stream or if I'm just going to do it tomorrow, but the things that I want to say down here in section 9 is stuff I've said in public before, but basically the idea is going to be, a lot of these ideas that managing memory is really hard come from the days back in the C days when C compilers were really terrible, right? And that the benefits of things like garbage collection are not as good as people say. Like, for example, when they say GC is fast, they say compared to C that mallocs all the time, right? Where if the vast majority of your allocations are like temporary storage, then you're faster than a GC automatically, right? So I basically want to say, well, if we actually care about the programmer experience, we can build in a lot of safeguards that tell you when you accidentally free things, or things don't belong to the right heap or whatever. We can do that. And what else? Well, that's probably it. Like, just explaining that. And then I wonder if I should put any examples in, but maybe not. Maybe this one's just going to be all text. All right. Thank you, everybody, for coming by. I'm just going to sign off. How long did we go on the stream? Oh, look, I have video going. 3.5 hours. That wasn't too bad. Yeah, thanks, everybody. And maybe I'll be on tomorrow. I still am in this same hotel tomorrow night. Sunday, I'm going. I don't know where I'm going Sunday. I don't know where in the world I am going. So Sunday, maybe not. Am I in Charlotte? Yes. All right. Thank you, everybody. See you later.